From models to autonomous enterprise systems. Instructor Shankar, Chief Architect, SystemBaseLabs. Hello everybody, this is Shankar from SystemBaseLabs. Welcome back to the course From Models to Autonomous Enterprise Systems, Module 3, The Rise of Deep Learning Systems, Video 3 of 6, Class 15, Computer Vision and CNN Architectures. Now, in our previous session, we explored neural networks and representation hierarchies. We discussed how neural systems started learning layered intelligence structures, how machines moved from shallow prediction systems to hierarchical representation learning, and how the transformation became one of the foundations of modern AI cognition. But today we move into one of the most revolutionary breakthroughs in artificial intelligence history, machine vision. More specifically, computer vision and CNN architectures. Now, think about this carefully. For humans, vision feels effortless. You look at a road and instantly recognize cars, people, traffic signals, movement, distance, risk, context, and behavior. Human visual perception is extraordinarily advanced. But for machines, vision was one of the hardest problems in AI history because machines do not naturally see images the way humans do. A machine initially sees only numerical pixel values, nothing more, no meaning, no context, no understanding, just mathematical patterns. Now, this created a massive challenge. How do we teach machines to recognize visual structures? How do machines identify objects, pattern, faces, movement, anomalies? And this is where convolutional neural networks changed artificial intelligence forever. Now, let us simplify this practically. Suppose a machine receives an image of a cat. Earlier AI systems struggled badly with this problem. Because traditional machine learning required humans to manually define visual features, edges, shapes, textures, patterns. Humans had to engineer vision manually, but CNNs changed that completely. Convolutional neural networks started learning visual representations automatically. Now, this was revolutionary because the neural architecture itself started identifying edges, corners, textures, shapes, object structures, and eventually complete visual representations, layer by layer, hierarchy by hierarchy. Now, pause there for a moment. Think carefully about what happened architecturally. Machines were no longer merely processing images. They were learning visual perception systems. That changed AI forever. Now, the word convolution here is very important. A convolution operation allows neural systems to scan images using small pattern detectors called filters. These filters move across the image, identifying visual signals. Simple patterns first, complex patterns later. Now, deeper layers begin recognizing eyes, faces, vehicles, animals, human posture, road conditions, medical anomalies, industrial defects, and highly abstract visual structures. And this dramatically improved machine vision capabilities globally. Now, from an enterprise perspective, CNN architectures transformed entire industries. Healthcare systems started analyzing medical scans. Manufacturing systems began detecting industrial defects automatically. Retail systems enabled visual product recognition. Autonomous vehicles started interpreting road environments. Security systems improved facial recognition capabilities. Agriculture systems monitored crop health visually. Defense systems accelerated surveillance intelligence. And suddenly, computer vision became operational infrastructure. Now, another important breakthrough happened during this period. ImageNet, very important historical moment. Large-scale labeled image datasets enabled neural systems to train on millions of visual examples. At the same time, GPU acceleration dramatically increased training capability. Now combine massive data, GPU infrastructure, and CNN architectures, and machine vision capabilities exploded globally. Now, this is a critical architectural insight. Computer vision succeeded not because of one breakthrough alone. It succeeded because of the convergence of data, compute, neural architectures, and scalable infrastructure. Very important pattern in AI evolution. Now, of course, CNN systems also introduced major operational concerns: bias in facial recognition, surveillance ethics, privacy concerns, explainability limitations, adversarial attacks, governance complexity. And enterprises quickly realized something important. Visual intelligence systems are powerful, but they also require responsible operational controls. Now, another major insight: CNNs did not simply improve image recognition, they changed how machines perceive the physical world itself. And that became foundational for autonomous vehicles, robotics, industrial AI, and medical AI, surveillance systems, multimodal AI, and eventually agentic AI systems operating in real world environments. Now, before we close, I want you to remember one important insight. Computer vision gave machines the ability to perceive visual reality, and CNN architectures became one of the foundational breakthroughs behind modern AI perception systems. Now, in our next session, we continue Module 3, Video 4 of 6, Class 16, Sequence Models, RNNs, and Language Learning, where we will explore how machines started understanding sequential information, language patterns, memory flow, and contextual relationships over time. Thank you, everybody. This is Shankar from SystemBaseLabs, engineering the future of intelligence together.